So storage classes, that means we have already seen one thing, memory layout of C program. Memory layout. So I will revise that. We have four sections: text section, if section, data section, and code section. Code section is the read section or text section. Data section has a undefined data and defined data are stored in the SBSS format, BSS format, or the in the data format. And heap section and stack section. This is the memory layout we have seen already. Okay. Now storage classes, we have a different things. So we have already seen which things is stored. I will revise that also today. So one is there is the four types of storage classes. One is the auto storage class. Second one is the static. Third is extern. And fourth is register. So this is the four types of storage class available. So there is what are the things available. So first one is the storage type. We have seen this type qualifier in C language. So type qualifier are the constant or volatile. What is the constant? That whatever the variable we are taking constant, so we cannot able to modify that data later. And volatile, that means we cannot able to create duplicate memory in the register. So every time we are informing the compiler to my code data will change. So don't make copy of my variable. So I will update every time my value of the variable. That is the volatile. So two types of type qualifier. We have seen the size. There is different size: long, double, long. Sign of the variable, that is the sign or unsigned. We have a data type. We have seen different. There is integer, character, float, double, integer pointer, character pointer, like this way. And variable name, you already know the variable name, how to take all the things. In the storage type, this will be decided by the compiler. So compiler will decide. So what compiler will be decide? So by seeing your variable name as a type, that is the static or extern, that is the auto variable or the register variable. So that is the size and what are the sign of that, what are the variable you have used. That all things take and compiler will decide that what will be your default value. So that is compiler will decide by also seeing storage classes first. So which storage classes you have used, then compiler will decide what is your default value. That is the garbage value or zero. So it depends on which storage class you have used. That is garbage or zero or anything else. Where memory will store. So inside the memory layout, which stack we need to store, that also compiler will decide seeing your storage classes, which storage classes you have used, then it will decide that which memory will be allocated. So where memory, what is the scope of that? Scope, that means it's within the file only, so we can use in another file on also within the function only. So like this way, that is the scope. So scope, that means we can say it's visibility. And last one is the life. So life of that variable. So within the function, within the file, within the program, what is the life? So memory can created and memory can destroyed. So write down this all the things. So storage class is applicable to variable and functions. So there is static and extern are the function and variable we are assigned. So now we will see one by one all the storage class. So I will start with the auto storage class. This done, right? Storage class is applicable to variable and function, static, extern, function and variable. This we will see later also. So first one is the auto storage class. So auto storage class is within a function, or we can say local variable. So inside function, whatever the variable we are taking, this variable called as a local variable. So local variable are the type of auto storage class, auto variables we can say. So within function or local variable. Outside the function, that is called global variable. So this is not type of auto, but for general information, I am writing here outside function, that is called global variable. Local variable without any storage type is treated as auto variable. Local variable treated as auto variable. Instead of writing like this, I will write here in the text how to increase size. Otherwise, I will move to here. The first auto variable, local variable without any storage type is called as a is treated as a auto variable. All the auto variables or local variables. So all the auto variables are the local variables, but all the local variable may not be an auto. So these statements are the all the auto variables are local variables, but all the local variables may not be an auto. So this statement meaning is that suppose I have taken this my function, this is my main function. Otherwise I can say this is my string copy function. Here also I have not taken any variable. Here you can see my string length function. I have taken this variable. So this variable is called as a auto variable. But suppose I have written here some other storage classes like static and all things different. So this is local variable are not auto variable. So all the auto variables are the local variables, but all the local variables are not an auto. So this line meaning is this: all the auto variables are local variable, but all the local variable may not be an auto. So it is not possible to use auto keyword as a global, and we are not using auto keyword as a local also. So otherwise compiler will generate error. It is not possible to use auto keyword as a global. Global, that means above main. Otherwise compiler will generate error. Okay. Next is the memory section. Auto variable are stored in a memory stack frame. Function stack frame. That means stack section. So we have seen stack, heap, data and code section. In 4 section memory stack section, auto variables are stored. So auto variable stored in a function stack frame. So how it's a function stack frame it's stored? So just so this is my main function. Inside the variable I have taken integer ij. Then I am calling the abc function. So my call go to the abc. So inside abc I have taken m and n, and I am calling the function def. Then this is my def functions definition. Inside that I have taken integer op like this way. So when we call abc function from the main, so it command goes to abc function. Once it's running and we are calling the next function, so command go to directly def function, and once it complete, it came back to here, it came back to here. So this is my stack section of memory. So inside stack section, this is my main function area, this is my abc function area. So when I will call the main function starting, so here memory will get created I and j, two variables. And when we call the abc functions, then my memory will created in the stack section of ram. Temporary memory here created an abc function. Here I am taking another variable m and n. So m and n variable, and whatever the stack pointer value of this df function is stored inside my abc function. So what is the starting location of s- last location of this, that is called stack pointer. So stack pointer address will store at here in the stack pointer of your controller. Here also stack pointer store the address of the abc function. Here stack pointer store the address of the df function, and then a command goes to df function. Again my memory will created an o and p like this way. Once we complete this df function, this memory will get destroyed or deleted from ram. Again we will come to this function. Once abc function complete that task, that memory will created in the ram will destroyed or deleted. Then after command goes to the main function, and main function will do their work. So like this way our code is working in the RAM. Suppose you take n number of function and you are calling from abc to df and df to another function, and like this way. So your stack will full. Once stack will overflow, you cannot able to store next data inside that. So your code will get stuck. So that is called stack overflow. So we'll see what is exactly stack overflow and all things when we start the recursion inside the recursion. So you need to know about that, how the memory is created and how these things. So write down these things in your book. So this is called function return address. Stack pointer is holding function return address. So we have already seen in the auto variable in the stack section memory layout is holding the auto variables function return address, each and everything we have already seen. Okay, done.
Yes.
So yeah, this understood basics things. So auto variable are stored in a stack section. So stack section of the memory, how it thinks, and you have seen that when somebody calls the function, so memory is created at the time. When that task is completed, memory will get destroyed or deleted from the stack section. So in stack, what stack is called? Function return address, auto variable, all the formal arguments. So what is the formal arguments? What is exactly the arguments? So when we call the functions at that time, whatever we are sending, this is called arguments. So this is my s and d, this is called arguments. So that is also stored inside my auto section. So this is the s is my, here we have created the variable, this is also stored in the auto variable. So this is called formal arguments. Okay, so auto variable are created in function stack frame. Next is the auto variable scope, or we can say visibility. What is the scope of auto variable? So scope of auto variable is within a function only. So where we declare within that function, that is the scope of that variable. Scope of auto variable is within function only, or we can say within a block. So for example, I will create, I will take integer I is equal to 10, and here I will take, this is auto we know, otherwise we can take auto keyword also. In locally it's possible, but globally it's not possible to write. So printf, what will be my I value? So I is equal to percentage d slash n, my I value is 10. Now I will make one block. Inside block I will take integer I is equal to 20. This is my first I, and I will take one more thing. This is my second I, and this is my third I. So what will be output of first I, and what will be the output of second I? What will be out of my third I? What will be output here? As expected 10. What will be as expected here? 20. So what will be output of this third I? 10 or 20?
10,
Why 10?
because it's a auto variable, not int 10, and within the in the block there is a int I is 20, so that is visible to in the block only, and auto variable is in the function.
Exactly. So as we have written here, the scope of auto variable is within a function only or within a block. That means wherever we have declared, that is the scope of my variable. So here my integer I is equal to 20 is created. This is also auto variable. So you can write here also auto. If you will not write here auto and here also auto, that's also okay. So this is both are, if we will not write anything, this is also auto, because inside the function whatever the variable we will take, that is the auto variable. If we will make here static or like this way, then only it will be the other variables. Otherwise by default it is a auto variable only. So write down this. So the scope is within a block or within a function. So here my I is created and I is destroyed once this colon is completed. Then after it started, it is taking my original I only, that is the inside the function scope. So once this scope is completed, this I also destroyed. Then this,
Yes.
okay, sorry Pooja.
Yes, ma'am.
Okay, so next the fourth thing is the life of the auto variable. Today we will see only auto variable, tomorrow we will start static variables. So life of an auto variable. So what is the life of auto variable? So life of an auto variable starts when the function stack frame gets created, and life ends when function stack frame get deleted. So as I explained, when we called main function to ABC function, that stack frame will created. Once that task will completed, that stack will destroyed. That means that life of an variable also get destroyed. So life of an auto variable starts when the function gets created, life ends when function gets deleted. So one important note is there, when we are designing a function, we should not return the address of auto variable. We should not return the address of auto variable. What is the meaning of that, this line? When we are designing a function, we should not return the address of auto variable. Suppose I will call from main function to, so this is my main function. Inside that I have taken integer I is equal to 10. Then I am calling the ABC function. address of I. So inside ABC function, I am creating void ABC and integer star p, printf percentage d slash n star p. So this is okay. So inside the main function, you are calling the ABC function, ABC address of I, and into the main function, its command goes to ABC function. This is right. This is okay, valid. But if suppose I will write my code like this, so first write down this, then I will erase this and then okay, done.
Mm-hmm.
Okay, so this is okay. When we are creating the integer I is equal to 10 and ABC function, we are passing the address of I and we are storing in the pointer and we are accessing that. This is completely okay. Why? Because once ABC function complete that task, it function get destroyed and command goes to the main function. So this is completely fine. Suppose you will do like this way, main function integer star p, p is equal to ABC function. Here, this is my integer pointer is the return ABC function and the argument is void. Here, integer I is equal to 20 and return address of I. So this is not valid case. Why? Because this is my memory area. I am calling the p is equal to ABC function from the main function. So this is my memory area of main function and this is ABC function. So once we call the ABC function, it command goes to ABC function and inside the ABC function we have taken I is equal to 20. This is my local variable that is called auto variable and we are returning the address of I. So whatever the address we are returning, that access to main function, but once this command is completed, this area is get deleted or destroyed from the RAM. So we get here, that is the garbage number. So that is called dogging pointer, dongling pointer. So we, that is not exactly the dongling pointer. So what is exactly dongling, we will see, but that means here it's get a garbage data or any destroyed any deleted data part. So data maybe, so here once you will uh, uh, return the address of I, this ABC function data will destroyed. So because of that reason, this is not valid case. So in this case, I return address to the pointer. So which is an auto variable to the second block. So because of that reason, life will get destroyed and that is the not valid case. So because of that reason, we have written in the not. When we are designing a function, we should not return the address of an auto variable. You can return the address of an variable if that variable should be global. If your variable is auto, then this is not valid case. So write down this.
Hey, Yogin,
Yes.
if here in the function in ABC function, if it's like extern here, extern int I, then it would be valid. When that function will be valid?
Yes, extern, that is the complete different thing. We will come to that part tomorrow or day after tomorrow.
Mm-hmm.
Yeah, then it's valid because extern the scope is within the program, not
Mm-hmm.
only within the file, but within the program you can take n number of file and all things. Then it is valid. Yes.
Mm-hmm. Okay, so it depends on this function, not the above main functions, no?
Yes, because this it depends on totally which type of your variable. Your variable is auto variable, then that life will get destroyed. If your auto variable, if your variable is static variable, then static is the different thing, that scope
Mhm.
is the different. The scope is within the file, so that it is okay in the
Mhm.
case of static, or
Okay.
external or different. Yes.
Okay. Thank you.
Main thing is you need to know about the what is the scope of your variable, and what is the life of and your variable, and which memory stack it is storing. So these three things is main important things: memory section, scope, and life of an variable. If you know these things, then only you can make your code as much as good. So if you make this type of code, this is the bug of your code. Your system will runtime will get destroyed. Here you will not get any error here at the compile time. Your data will get destroyed. Your you will not get expected data, and your system output will not work. Okay, that's it for today. Tomorrow we will see the static storage class.